Hello everyone, welcome to our YouTube channel Code Logic. So in this series we are seeing the faang interview questions. So in our previous video we have seen the how to find out the middle element of the linked list. So in this video we are going to see how to find the loop in the linked list. So the problem statement is like this. You will be given a linked list of n nodes, and you have to find out the if there is a loop present in that linked list or not. So suppose this is our link list, and you can clearly see this is a loop present in this link list. So expected time complexity is O of n, okay, and the auxiliary space complexity is O of n. That means we cannot use extra space. So how to tackle this problem? So there are different ways to tackle these problems. So we'll see all these ways. So first approach is using extra space. Okay, so how we are going to do this? So we can store the addresses of each node, okay, inside a set. As you know, set will contain only the elements which are not duplicate. Okay, so while traversing the linked list, we can check if the address is present in the set or not. So if address is present, that means we can say that loop is present. Okay, otherwise we'll move to the next node till the end of the linked list. So if a loop is not present, then we will encounter the null node. Okay, so in this case the time complexity is of n, but we are exceeding here space complexity. So next method. So in this method, you can see we can update the node structure. So in our node structure we can create a new variable boolean visited. Okay, so while traversing we can update this variable to set true. Okay, uh, that means if we have visited this node already, then the value of this boolean variable will be true, and that by that mean we can say that loop is present inside that linked list. Okay, so another approach is there, last approach, slow pointer fast pointer solution. So this is a best approach to detect a loop is present in linked list or not. So we'll see in detail now. So now let's start with the demo part. Suppose we have two pointers, slow pointer and fast pointer. So initially both the pointers are pointing at 10. Okay, slow pointer and fast pointer. So at first iteration what will happen is slow pointer move from 10 to 20. Okay, and the fast pointer move from 10 to 30. So here value changes. Slow pointer's value will be 10 and fast pointer's value will be 30. Sorry, slow pointer's value will be 20. Okay, so now both the pointers are at 20 and 30. So we'll move slow pointer by one iteration. So it will come to 30, and the fast pointer will come from 30 to 50. Okay, now we'll change its values here. So slow pointer is at 30 and fast pointer is at 50. Okay, we'll remove this. So fast pointer move from 50 to 70, and the slow pointer which is at 30, it will move from 30 to 40. Okay, in the next iteration we'll update the values here. So fast pointer is 70, slow pointer is at 40. So you can see both the values are not same. So we will break this loop when both the values are same. So in the next iteration the fast pointer will move from 70 to 90, and the slow pointer will move from 40 to 50. Okay, again in the next iteration it will move from 50 to, slow pointer will move from 50 to 60, and the fast pointer will move from 90 to 40. Here you can see 30, and 30 is next is 40. Okay, so in the next iteration slow pointer will move from 60 to 70, and the fast pointer will move from 40 to 60. Okay, so now I'll update the values here. So fast pointer is at sorry, slow pointer is at 70 and fast pointer is at 60. We'll remove these loops. Okay, we have removed this. Now our slow pointer is at pointing 70, so it will move from 70 to 80, and the fast pointer which is at 60, it will also move from 60 to 80. Okay, so now this loop pointer is exactly equals to fast pointer. Okay, so what this indicates is like we have the loop is present inside the linked list. Okay, so we'll see the implementation part now. So in this video I have written some code, so you can see here. So this is a class node inside which we have data and next node. Also created a constructor which will take a argument as a data, and which will initialize the data and pointer next pointer to null and data. Okay, also I have created a linked list here uh, with the using for loop and the method insert front. Okay, so what this method do is insert the element at the front of the linked list. I choose the insert front because it's of one operation. Okay, now here at line number 38 you can see I have created a temporary node which will points to head arrow next. That means head is at 10, so 10 arrow next is 15, 15 arrow next is 20. Okay, so a temporary node is pointing to the 20, and now temporary arrow next 3 4 5 times next. So its next is 25, second next is 30, third next is 35, and fourth next is 40, and then its next, that means 40's next is null. So we are reversing this its link. So 40's next now will point to the temporary node, that is 20. Okay, so that means we have created loop here from 10 20 40, 20 to 40, and then 40 will point to again 20. Okay, now we'll write a method to detect loop is present or not, and we'll pass the head node here. We'll check first if head is exactly equals to null, or head arrow next is exactly equals to null. If that is the case, then we'll return from here. Also we write a message loop is not present. Okay, now we'll check here for the loop. So that's why we'll create two pointers, slow pointer which will contain head, and the fast pointer which will again contain the head node. Now while loop, slow pointer is not equals to null, and then fast pointer is not equals to null, and then fast arrow next is also not equals to null. If that is the case, then we'll go inside the loop, and then we'll move fast pointer to fast arrow next, and then we'll move slow pointer to slow arrow next. Okay, I've done some spelling mistake here. Now it will came out of loop uh, when there is a null in any of this condition. slow, fast, or fast. Okay, fast arrow, next is null. Now we have to check if slow pointer is exactly equals to fast pointer. So if this is the case, then we have to return it with a saying loop is present. Okay, and in other cases we'll return message loop is not present. Okay, now it's time for we to check our code. So we'll run our code. Okay, you can see the loop is present. Now we'll comment this uh, temporary code here and then again run it. Okay, you can see loop is not present. So that means our function is working properly. Okay, so yeah, that's it for the video, guys. Thank you for watching the video, guys. If you like the video, please like, share and subscribe, and don't forget it to share it with your friends. See you in the next video. Till then, bye bye.